So back to unit 7, this was your exponential logarithmic unit. This is asking for end behavior. So let's just go ahead and set it up. Limit x goes to negative infinity f of x. Limit x goes to positive infinity f of x. Again, on the test, you won't have to write that because it is multiple choice. Now, one end is going to level off at the asymptote, so it'll be like a number. The other end is going to either go up or down. We're just going to draw off to the side a really brief sketch, not the Mona Lisa of graphs or anything, just a real rough estimate of what it would look like. Did this graph move up or down? Down 4. Do you see that? -4. So you're going to go down 4, dot in an asymptote. And it's going to be a swoop. Instead of swooping up, I know it's going to swoop down. How do I know that? Is the negative, a reflection. All right, so it is going to look roughly like that. So easy peasy, just a real quick graph. It's not, again, I didn't even plot any real points. It's just a rough estimate. So where is the left arrow pointing? Yeah, up, positive infinity. The right one, -4. All right, vertical asymptote. Vertical is x equals, now it's typically 0 unless you shifted left or right. So did this graph shift left or right? It went right 7. So x equals 7. That's it. Don't overthink that. Hey, Ms. Cole, will it be just like that on our test? This was that Quizlet game we played. 2, good. It's 2 to what power gives you 1/8? Well, 2 cubed gives you 8. We just flipped it, so that's where the negative comes in. So -3. All right, 3 to what power gives you 1? 0. And it wouldn't even matter that it's 3. It could be 7 billion. Anything to the 0 power is going to give you 1. All right, expand. You're not really doing any math with this. It's sort of just a puzzle. You're getting all the pieces in the right place. You're going to bring that 6 down. It's going to be 6 log A. Yeah, plus, you guys liked these because you're not really doing it. I remember you guys liking this and being like, okay, we got it. Now, for a square root, it is 1/2. For a cube root, it would be 1/3. Okay, log B. Good. Why is it minus? You're dividing. Good. Yes, you guys got this. And then it's 5 log C. No. Yeah. They're both negative. Yes. And again, it'll be multiple choice, so you kind of won't be able to mess that up because you'll just look at them and know which one is the answer.
So if there was something like next to this power, it would be another minus.
Correct. Like, for example, if this square root of b was on the bottom, this would just be negative instead. Anything that's divided is going to be subtracted. All right, for a right triangle, so go ahead and draw yourself a right triangle. Or actually, you know what? We don't even need to draw a picture for this. It's that easy. You know what? I got rid of my whiteout. So I'm going to finish drawing my triangle anyway, even though we don't need it. Just forget that. We have A and we have C, find B. It's Pythagorean theorem. So it's going to be 6 squared plus B squared equals 9 squared. I'm not going to narrate our way through this. Everybody just go ahead and sort that out, and we'll just all make sure that we get the same thing, okay? No, I didn't finish it. We'll finish it together. Did you get down to a 45? Yes. Okay. Now, when you square root, you have to split that. So 45 will split into what times what? Yeah. 9 times 5. And then the whole purpose of doing that is you can square root 9. So 3 square root of 5. Is that what? That's the answer. All right, now we're getting into unit circle stuff. Find a negative coterminal angle. Coterminal means they start and end at the same place. They all start at 0, but they're going to end at the same place. You don't have to draw this. Again, it's multiple choice, but if it helps you to have a visual, what quadrant is 4/3 in? The third. So it would look like this. What you need to figure out is how much backwards we're going to go to land at the same place. And it's going to be something thirds, and it's going to be negative. Negative how much thirds will make you land at the exact same spot. It has to be thirds.
I'm confused right now.
Let me rephrase. Yeah, we went forwards 4/3. How much backwards would you have to go to land at the exact same spot? Now, the reason it's two negative because you're going backwards, 2/3 is because 4 plus 2 is 6, and 6/3 is the whole way around.
If you go into the same direction, what we need to get 2/3 to get to that.
To that location, yeah. For example, because that didn't go super great. Hold on. Let's say it was 7/6. So I just drew, you don't have to write this. I just made up another example since that seemed a little rough. 7/6. How much backwards would you have to go? It's going to have to be negative and something 6 to land at the exact same place.
Oh, wait.
Yeah, because 7 plus 5 is 12 and 12/6 is the whole way. Okay. In what quadrant is 2/3? That's literally just 1, 2, 3, or 4. 2. Good job. All right, this is your all students take calculus. Although I'll be honest with you, the way I think of this is just whether it's positive or negative. If you want cosine to be positive, cosine is the x value. So if you want that to be positive, you had to go, 1 or 4. So it can't be either of these. And we want tangent to be negative. Well, if something's negative, it can't be quadrant 1, so it has to be 4. I kind of just do those by process of elimination. But if you liked this, if that helped you, I show this to you guys, but to be honest, this is not really how my brain does it. So, but everyone thinks differently, so however it works for you. All right, reference angle. This might be one of the easiest ones on the whole thing because the denominator just has to match. So it is 5/6. Denominator has to match. All right, and then we'll do one more and take a break. All of these are positive, so we are in the first quadrant. Hey, Ms. Cole, is it like that on the test? Yep. Cosine is 4/5. Cosine is adjacent over hypotenuse, so that's how they get placed. I don't even really need to give you this piece of information because we should know that the other side is 3. Now I'll talk you through this. Cosecant. What function, so I'm looking for like a word here, is the reciprocal of cosecant? Sine. You don't have to write this, I'm just illustrating. Sine is opposite over hypotenuse. So we want this to be hypotenuse over opposite. So that would be 5/3. It helps to talk through it. Sometimes I feel bad that you guys can't like talk things out while you're taking a test. It has to stay silent in here because it helps to even just say it out loud.
Yeah, I whispered myself.
Whisper to yourself.
So are we gonna?
All right, so these are your conversions. We're going to take our 50 degrees and we're going to multiply by pi over 180. So the degrees cancel and the zeros cancel. And you get 5 pi over 18, which does not reduce. So that is your answer. I can't remember if the fraction reduces or not, but you guys know how to reduce fractions. So if it does, then just do that. All right, 10 pi over 9. This time we're going to multiply by 180 over pi. And you almost can't mess it up because if you get it backwards, the pi's will not cancel. Now here's how I taught this, how I suggested you to do it. Do not do 10 times 180. All right, you want to keep the numbers little. Just keep the 10 there for a second. Put your little multiplication dot. And we're going to do 180 divided by 9, which would be what? It'd be 20. And then you can easily multiply 10 times 20 to get 200. So divide first, then multiply because it'll keep the numbers smaller. Now, this was the topic where I said, if you do not have a labeled triangle, I'm not giving you credit. On this exam, it's multiple choice. So I'm not grading your work. So if you can do it in your head, you can't. Yeah. But I will tell you, people that try to do it in their head, get it backwards. All right. Yeah. So we're going to just label the whole, this is the bread and butter of pre-calculus. Like when you waltz out of pre-calculus, this is, unit circle is what you got to be able to do. What quadrant is pi over 3 in? First. Good. Across from pi over 3 is square root of 3 over 2. That means other side is a half. Again, I can't fault you if you don't write that. And if you're able to do it in your head, cool. But if you get it backwards, you're going to not be happy. All right, then tangent. Tangent is y over x. So if you put square root of 3 over 2 over a half, what does that reduce down to? Yep, just square root of 3. Perfect. All right, negative pi over 6 is going to be in the fourth quadrant because you went backwards. A sixth is a little slice. You have a sixth of pi, that's not very much. So across from that, 1/2, but it's negative. Other side, square root of 3 over 2. Perfect. Now this one says sine. Sine is the y value, so negative 1/2. Again, this is like the bread and butter of pre-calculus, is your unit circle, right? 5/4 is in quadrant 3. It's your pi over 4 triangle, and so both sides. What's wrong? What happened? Square root of 2 over 2, the fourths. If it's pi over 4, something pi over 4.
The denominator is always the same.
Yeah, denominators stay the same. Can't change it. Cosine is the x value, which is negative square root of 2 over 2. You actually couldn't mess that one up because they were the same. All right, 3/4 is in the second quadrant. It is practically it is the exact same triangle that we just did, except reflected. And the y value is positive now. It's literally it's the same triangle we literally just drew. All right, cosecant. That means you need to flip which one? Close. Y. So it's the reciprocal of sine. You're going to flip the y value. So it will be 2 over square root of 2. And heads up, because it's going to look like a million 2's here. When you rationalize, it is, 2 square root of 2 over 2, which just is square root of 2. I usually try to get people to remember that if you flip that, it's just square root of 2, so you don't have to do all that, but that is how it works out. Yeah, hopefully. And again, there's only 4 choices, so one of them. All right, if you go backwards 7/6, that's going to put you in the second quadrant. You would go backwards 6/6 and then a little further. So your reference angle is pi over 6. Across from that, 1/2. And so the other side is square root of 3 over 2, but it's negative. And it says cotangent. So cotangent is what over what? X over y. So it's going to be this one over this one. And if you can do that in your head, you don't have to write it. But it's this one over this one, which is going to reduce down to, negative square root of 3. Just watch your negatives. That's usually the only thing that gets people. Because one of the wrong choices in multiple choice is going to be like the negative or not negative version, positive version. I don't know. I said not negative. That was stupid. All right. 5/3 is in fourth quadrant.
Will we get like partial credit still?
No, because multiple. Yeah. So that's the only thing about multiple choice is number one, 3 of the answers are wrong. So that,
What if I got worse?
I'm not looking at it.
Oh, because you just have like the answer.
Yep. That's the thing with multiple choice. It's nice and then it kind of isn't, but.
Okay. So
It-
at least you know if it's like a crazy answer, it's like.
This exam is usually pretty good. Again, I never need to curve. I don't think I've ever curved this final because it's always just fine.
Okay.
All right, across from pi over 3, you're going to have negative square root of 3 over 2. Other side's a 1/2. This one says secant. For secant, you flip x. So if you flip 1/2, you get 2. Now these last 3, look at them for a second. Pi over 2, 3 pi over 2. These are going to be all your circles. So up, down, left, or right, where is 1 pi? Left, good. So tangent is y over x. And I know at that point, everyone's like, oh my gosh, is it 0 or is it undefined? Which one do you think it is? 0. Undefined is when you try to divide by 0.
Zero cookies and you give it to one person.
Yeah.
You get 0, but if you have one person and 0 people.
Yeah, like you can't divide into, the way I always explain it is I'm like, hey guys, divide yourselves into 0 groups. Go ahead, I'll wait. Like you can't do, because you can't unexist,
You can divide one person.
This one is up, yes. So 0, 1, and it says sine is the y value, so 1. And then 3 pi over 2 is down. It's secant. That means you want to flip the x value. So that is where you get a 1/0. You can't flip 0, so that's where you get an undefined. And I don't know if you've noticed, I do have these going through chronologically, like as the order I taught this to you in.
Yeah.
So like as we go by, we're getting to more and more recent things. All right. So using this function, we're going to answer all the characteristics. The first thing I would do, like I told you on the test, is take that 4 and put it at the end. That just always messes everybody up when it's at the beginning, but it means the same thing. And actually, out of these choices here, what is that for? Which one of these things is that? Yep, good. That's your vertical translation, up 4. Amplitude is not -3.
It's positive.
It's 3. You have to absolute value that. An amplitude is a distance, so it cannot be negative. I would do the period next. Period is 2 pi over whatever's in front of the x, or if you want to think of that as the b value. So 2 pi over 1/3. Now, if you divide by 1/3, you multiply by 3. So 2 times 3 is 6. So 6 pi. I'm going to draw a picture for the range. Your center line is at 4. Do you remember us doing the word problems? And we drew these out. That's kind of what this is like. Your center line is at 4, and your amplitude is 3. So what's going to be this low point, your minimum? Yeah, good. 1. 4 minus 3 is 1. And then your maximum will be 7. 4 plus 3 is 7. Now, to get the phase shift, you have to factor this. If you're like, I'm uncomfortable factoring, it's the only thing you won't be able to get. But you're going to factor a 1/3 out of there. Again, dividing by 1/3 is the same as multiplying by 3. So if you imagine just multiplying a 3 through here, you're going to get x minus 3 pi. And so your phase shift is 3 pi. Again, if you were like, yeah, that's going to be a nope from me, I can't factor out a fraction. Well, first of all, I believe in you. I think you can do it. But if you're like, I just can't get that, that's the only answer you won't be able to get. You'll be able to get the rest of it. You guys are all flipping. I was kind of expecting a question there, but are we all right? If you are, I'm happy. So this is what we just did on the other page, except backwards. So you have the sides of the triangle and you're looking for the angle. The only thing is these are very picky about what quadrants you're allowed to be in. All right. This is positive, so I know it is quadrant 1. You don't really have to worry if things are positive. And it's not on the unit circle. We're back to SOHCAHTOA. So cosine is what over what?
Adjacent.
Yeah, good. So this is the 3 and this is the 5, adjacent over hypotenuse. The other side is 4, okay? Now it's kind of like your work. We're going to do tangent of that triangle. So tangent TOA, that's opposite over adjacent. So 4 over 3. I think the rest of these are on the unit circle.
So what is the arc toss again?
Arc cosine.
Oh, yeah.
And that's what allows you to set up the
Oh.
triangle. Yeah. That tells you the placement of where the numbers go.
Oh,
All right. Now this one's negative, so it's not quadrant 1. Cosine what's the other option of a quadrant for cosine? 2. Good. So quadrant 2. And the other way you can remember that is cosine is the x part of the point. So if that's negative, you have to go to the left. So other side, square root of 3 over 2. And so what is the reference angle? Pi over 3. Good job. But that's not your answer. Your answer is how much you rotated to get there. So it's going to be something pi over 3. It has to be thirds. Yeah, 2 pi over 3. I made you fill out enough unit circles, so that should be, have that in your back pocket. This one makes you feel like it's a circle, but it's not. It is a triangle. And what is your other quadrant that's available for cotangent? Because it's negative, so it's not going to be quadrant 1. None of them are in 3. 4.
Wait, why are you not in 3?
Remember, they're either 1 and 4 or 1 and 2. Do you remember when we did that lesson and we took out our highlighter and we highlighted the parts of the graph that we were allowed to keep and you could only rotate so far?
Yeah.
You can rotate out of quadrant 1 into 2 or out of quadrant 1 backwards into 4, but you can't make it into 3. Remember, the bridge is washed out. You can't make it to the other side.
Yeah.
All right, now what are the sides so that you can end up with 1, or in this case, -1? Yeah, they have to be the same thing, except this one's negative. And then here's the whole point. What is the reference angle? Pi over 4. That's not your answer because you went backwards to get there. It is -pi over 4. What is what? That's not a negative power. That means inverse. That means the same thing as arc. Those are two ways. Well, and that drives me insane too. Why do we have two ways to say the exact same thing? Couldn't we have picked arc or like the -1? Those both mean inverse. That's why I made some of them written some way and some of them written the other. They mean the same thing. All right, this one's positive, so quadrant 1. Sine is the y value. And so what's your angle that's across from square root of 3 over 2? Yeah, pi over 3. And if you're in quadrant 1, that just is your answer. Now, if you have a secant or a cosecant, you have to reciprocate. So which function, like I'm looking for a word, is the reciprocal of cosecant? Well, that is going to be a 1/2, but I'm looking for a word. Sine, good. So it's going to be sine inverse of 1/2. And so it's almost the exact same triangle we just drew for this one, except it's a 1/2. And so what's the angle? Pi over 6. And then that's your answer because you're in quadrant 1. This next one was the identities. I made them all ones you could do without doing any work though. All right, they're all like just answer it. Cosine over sine is cotangent. Reciprocal of secant is cosine. Good. The even ones turn positive, the odd ones turn negative. Tangent is odd, so it'll be negative. This is one of the Pythagorean ones. You can either write them all out or you can remember that the cos go together. So this is going to be cosecant squared. And then the 90 minus, that's the co-function. And this is why I harp on about saying them correctly. You're going to add or remove a co. How do you say this one? Cosecant. So if you remove the co-secant, all right? So I made them all, like it's on there. The identities are on there, but they're like surface level ones. Yeah, go ahead.
Number 35, the only ones that would stay positive, cosine and secant.
Cosine and secant would turn positive there. All the rest of them are odd. All right, and then here's our equations. Again, we're going more and more recent. This is what we did on the last test. To solve this, you would add 1, so it's going to be positive, and divide by square root of 2. So it's going to look like this. Now, if you rationalize that, you get, oh my gosh, and that's on the unit circle. We want quadrants where cosine is positive. Cosine's the x value. So if that's positive, you went to the right. So it would be 1 and 4. It's your square root of 2 over 2 triangle. And I didn't leave a lot of room on here, so let's just write our answers. It's going to be your pi over 4 triangle. So in the first quadrant, that's pi over 4. If you go all the way around to the fourth quadrant, 7 pi over 4. And again, I'm not going to be grading your work. So you don't have, like, I'm not yelling at you to label everything anymore. We already did that. We're past that. This one's just multiple choice. All right, for 39, you would add over the 1/3 and then square root. So when you put a square root, you have to put plus and minus, and you just square root the numerator and square root the denominator. So the square root of 1 is 1, and the square root of 3 is square root of 3. Now, I wrote these options on the board. Remember me going, it's this over this or this over this. It's not going to be up there when you take the exam. It's going to be 1/2 over square root of 3 over 2. Now, which quadrants are we in?
All of them.
Yeah, why is it all of them actually? Yeah, plus and minus. So you can already narrow down your answer choices in multiple choice. You know you're going to get 4 answers. Any choice that doesn't have 4 answers, you can get rid of if there's a plus minus. Now, cotangent is x over y. I don't have room to put the 1/2 in there for the x, but the y is square root of 3/2. And so what's the angle across from that one? Yeah, pi/3. So we're just going to go around the unit circle and put all the thirds answers. So, because you should have 4 of them. So pi/3, what else? Yep, 2 pi/3, 4 pi/3, 5 pi/3. I did not put any on there where you have to rotate more than once around. Do you remember those ones where it was like a 2x and you had to go more than once? No, that's not on there. It's exactly like this, okay? Now this one is solved for all solutions, so you're going to have the plus something n, okay? We're going to add 1, so it'll be positive, divide by 2. So I need quadrants where sign is positive. Sign's the y value, so you're going to go up. So it'll be, yeah, like kitty cat ears, 1 and 2. So we're going to have to write this as 2 separate answers because they're not evenly spaced from each other. What's the first one? What's our angle across from the 1/2? Yeah, good. Pi/6. Now you have to go the whole way around to get back to there. So plus 2 pi n. And then the other one's going to look practically the exact same, but in the second quadrant, it's 5 pi/6. And then you have to go the whole way around to land there again. Yeah, go ahead.
So if it was pi/4, like if that was the angle that you got, what isn't it always 1/2?
Only if you have the bow tie and it's in all of the quadrants. And you can add 1 pi n if they're exactly across from each other, because that's halfway around the circle. Okay? So take another little break, but when we get to the last one, I'm going to let you have your computer up for this, but the only screen you should be on is Desmos, because I want you to practice type in a minute. But we'll do one more little break and then we'll do the last page. So for the calculator ones, I'm going to share. Very first thing that you need to do is hit this little wrench, your gear over here. And does everybody see where I'm pointing at? And change it to degrees. Radians is the default, so you have to change it. If you do not do that, all your answers will come out wrong. Now, hopefully you will catch it, because if you're in radians, your answers won't make any sense. So you hopefully go, hey, wait a second. But you need to make sure that it is degrees.
It wasn't in degrees. And I didn't realize until after I took it.
Yeah, so you need it in degrees.
Hey, that's so bad.
Yeah, I'm recording, so let's keep on going. All right, so we're on number 41. You have been solving equations for a long time. I realize that's an exponential in there, but how do you get rid of the 7? Divide by 7. We're going to divide both sides by 7. So you get e to the power 8x equals 4. Now here's what makes it a pre-calculus question. How do you cancel out e? What is the inverse of e? ln. Perfect. You're going to ln both sides. I just wrote an ln in there. That cancels. I'm going to come up here. I didn't leave myself very much space. You get 8x equals ln 4. And then your last step is divide by 8. So I want you all to practice typing in the calculator ln 4/8. You will truncate to 3 places. You can't mess that part up because it's multiple choice. No, I'm not going to make your answer choices so close that you're, taking it to 3 decimal points. Like, you're going to be able to pick the right answer. Do you get what I'm saying? Did you get 0.173? Okay. The first 3 that you see. But again, like, for example, I'm not going to make one of your choices 0.172. You understand what I'm saying? That's not like how that works. They'll be different enough that you'll be able to tell which one's the answer. Okay. Now for this one, what is the base number? 5 to the power of 3 equals x minus 1. We got this a few more problems. Stick with me. So what is 5 cubed? Now you get a calculator, but I hope you do know that one. It is 125. It's 5 times 5 times 5. And then you would add over the 1. So 126. You almost kind of don't even need a calculator for them.
Will we? If we get a calculator for that one.
You can type it if you want. Can't stop you.
It's something that we didn't know would be able to-
Yeah. Yeah. All right. Do you see how this one has a plus sign?
Yeah.
That means you multiply the stuff that's inside the logarithms. These are your log rules. In theory, if there was a minus there, then you would divide. I didn't make it division. So you're going to multiply x times x minus 6. That's going to give you x squared minus 6x. And now this question is a lot the same as the one that we just did. What is the base number? 2. So it's 2 to the power of 4 equals like that stuff. Yeah. Now I'm just going to scribble out and rewrite it so that I don't have to write the whole problem again. What is 2 to the 4th? It's 2 times 2 times 2 times 2. That's 16. And then you need to evacuate so that it all equals 0. So you would subtract that 16 over. It's going to look like this. And you will factor and you will get 2 potential answers. I say potential answers because I think one of them is going to come out negative and you can't log a negative number. So we're going to have to get rid of that one. So how is this one going to split?
8 and 2.
Yeah, 8 and 2, whatever order you want to write it in is fine. Yep, minus 8 plus 2. So you're going to get x equals 8. Now this one would give you negative 2. And again, you can't log a negative. So we're going to get rid of that one. All right, now we're on to the trigonometry here. For a right triangle, so we're going to draw ourselves a right triangle. It doesn't matter where A and B go. You can put those wherever, but C has to be the right angle. So however you want to label it, I put A down here and B up here, but that part doesn't matter, but C has to be the right angle. So we're going to label the rest of this. A is 32, little c is 11. We want to find little b. So this is your SOHCAHTOA. Now 32 is what's labeled. So that's like you are here on the map. That's like the star, you are here. That means B is the what? Adjacent. Opposite's not labeled, so I don't have that. Adjacent and 11 is hypotenuse. So adjacent and hypotenuse means cosine. So it's cosine 32 equals B over 11. And then how are you going to type that in? Because we want to all go practice typing this. You're going to multiply the 11. Oh, I ended a pass, so sorry, I'm on there. You're going to multiply over the 11. So everyone go ahead and type that. Just make sure we can all do the same thing. I got 9.328. If I can get confirmation. I'd like to know if somebody got the same thing as me. I'm going to go and do 47 and 48 because they are very similar to this, except with words. So it's very much the same as number 44. So we'll kind of piggyback off of that. All right. So you are standing 200 meters away from a building. So where does the 200 go? Yeah, that's the horizontal. It's like you're out here and this is the building. All right. And then the building is 135 meters tall. We want the angle. So sine, cosine, or tangent. Tangent x equals opposite over adjacent. And then how do you type that if you want the angle? Yeah, it's inverse. So if you open this little keyboard, hit functions, it's one of the first things that comes up. So tangent inverse. And then go ahead and type it in and I'll make sure we get the same thing. I'm not going to finish typing mine because I want you to do it and then I'll show you what I got, make sure we get the same thing.
Wait, hold on.
You have to go in functions. Yeah, 34 and some change. And again, I'm not going to make one of the other choices 34.1. Like they're going to be different enough that you're not going to be able to mess it up. All right. Right triangle. let's read this and use our imagination. A ladder is leaning against a building. So the hypotenuse is the ladder, and then the vertical part is the building. The ladder is 18 feet long. So that's the hypotenuse. And it touches 13 feet up the side of the building. So that's the vertical part. And again, we want the angle. So that one's not tangent. What is that one going to be? Good, sine. We have opposite and hypotenuse. Everyone go ahead and type that one. Make sure we all get the same thing. Yep, and a little bit. Yep, perfect. So we're going to go back and get this last two. So your law of sines, law of cosines. So you're either going to remember it or you're not. It's only two questions. I did not put that ambiguous case on there. Do you remember that flow chart? It was for the naughty word spelled backwards. Do you remember that? It was like if theta is obtuse or acute. That's not on there. Okay. So it's like the topic is on there, but it's only two questions and I didn't make them the hardest ones possible. All right. Now an oblique triangle simply means it's not a right triangle. It just means there's not a right angle. That's all oblique means. You're going to start labeling in the bottom left. So that's where B is going to go, 42 degrees.
You always start wrong.
Bottom left. And then you go where? Do you remember where you go after that? The bottom right. And then you would go to the top. Now I don't have another angle, so I kind of can't do that. A is 13. So I'm going to go ahead and label that. And then C is 16. And we're looking for B. So what is your angle and side pattern? Look at the actual numbers you have in there. Well, we only have one angle. Side angle, side. Now that means law of cosines. Again, if you were sitting there going, I'm actually just not going to do this, Miss Cole, it's okay. It's only one question, but we're going to do it right now. Okay. We want little b. Here's what it is. B squared equals, and I want to see if anybody remembers this because I actually believe in you. And I think if I wait you out, someone will.
No.
A squared.
A squared, so 13 squared plus 16 squared minus, and it's not a 1/2, it's a 2. And then you just repeat those.
Oh, I remember this.
Yep, so it's that one squared plus that one squared minus 2, and then you just repeat them. And it is cosine, because it's the law of cosine, of the only angle you've got. Believe it or not, people usually do remember that. The most common mistake I get is people put sine instead of cosine, and I'm like, it's the law of cosines, guys. It's the law of cosines. So yeah, let me say it again. You had it there. You were like saying the whole thing.
C
Squared minus, and then you repeat those. Then you repeat those. I'm trying to explain it, but your voice is getting picked up by my microphone. You just repeat these, and then it's cosine of the only angle you have. Now, before you go and type, no one is typing anything yet. What do you do to get rid of the squared? But so what I would like for you to all do right now is type in square root of all of that. I'm going to do it too, but I'm not going to share my screen yet because I want you to all actually type it. I believe in you. I can do it. Oh, did I type something wrong? I was going to say that.
Wait,
Oh, I was going to say that answer doesn't actually make sense. There we go. Oh, there we go. That makes sense. Do you guys know how I caught that though? How I was like, wait, that answer doesn't make any sense. Got like 40 something. Look what I did. Looked at the other sides. This one's 13 and this one's 16. So did it make any sense for the other one to be 40 something?
Yeah.
No, like it has to ballpark be like, you know, it's similar, right? So did anyone else get 10.7 something? Okay, last one. For an oblique triangle, all right, so just draw yourself a three-sided thing. A is 72, start at the bottom left. C is 20, you go to the bottom right. The one that you don't have anything for goes at the top. And then baby B is 8. So what is our angle and side pattern? Yeah, now that is law of sines, which is a good bit easier. You need a side across from an angle. I have side 8, bless you. So I need this angle. How can you really easily get that angle? Yeah, so everybody go do that. Well, I'll make sure we get the same thing. Do 180 minus the other 2. That'll give you what the one at the top is. What'd y'all get? 88. I wish it had come out to something else because then that's also an 8. But so you need a side across from an angle. So it's going to be 8 over sine of 88 equals, what are we looking for? I forgot to put that in there. C, baby C. So it's going to be C over what? Sine 20. Let me talk you through how to type this and then I'll shut up and you can all go and practice doing it. You're going to cross multiply and you have to cross the way that you have both things, all right? So you're going to type 8 sine of 20 and then what? Over divided by sine of 88. Not going to share my screen yet. Everybody go ahead and do that. We'll make sure we get the same thing. Don't stop listening to me as soon as I finish this. Let me wrap everything up. But it's always rude when everyone just throws everything aside. Hold on a second, because I think I'm gonna have to go over there. I got 2.737. Is that what? Okay, everybody hold on one second.